Hello and welcome to part 3 of revising for the specialist exam. Now I've travelled all around Australia, I've read their past papers, and today I'm going to show you some questions that wouldn't look out of place on a Queensland Maths Specialist external exam. Let's go. Alright, we're in Victoria way back in 2008. Give yourself 90 seconds. And I'm going to solve it in 3, 2, 1. Let's go. Alright, so we're trying to find an expression for dHdt. And I barely have to read this question to know that there's some kind of related rates thing going on. So the way that I like to set this up is by writing dH dt and then trying to find what it is that I'm going to be, what's my intermediary thing here. And it looks like I've got a V there, so dV. Okay, and now I need to fill in the gaps. I've got some sort of relationship between V and H, which means that I'm going to be able to find the derivative of V with respect to H just by deriving that. And that's going to be equal to 4. Now, I don't want dV dH, I want dH dV. So, dH dV is going to be equal to 1/4. Alright, so I have 1/4 sitting right there. Now, the dV dt thing. Alright. Water flows into the tank at a rate of 0.2 meters cubed per minute and leaks out at a rate of 0.01 H meters cubed per minute. So that means that dV dt, the change in volume with respect to time, is going to be equal to the inflow minus the outflow. So an inflow of 0.2 minus an outflow of 0.01 root h. Alright, so that's my dV dt. So I'm going to put that in there, 0.2 minus 0.01 root h. And then that's being multiplied by 1/4. So that's what I think my answer is. Now the problem is that I don't see anything that's sort of neatly that. Not to worry though, let's write it just slightly differently and see if we can find something that leads us where we want to be. Alright, so what about 0.2 minus 0.01 root h on 4? I see a kind of a promising candidate in C here, right? I'm just going to move this thing out of the way so we can do this work. Instead of dividing by 4, what about we divide by 400? In other words, we multiply top and bottom by 100. Well, this 0.2 multiplied by 100 is going to become 20. This 0.01 multiplied by 100 is going to become 1, which just leaves me with the root h. And then 4, we end up with 400. All right, let's see if I've got it. 20 minus root h on 400. Great. I think the answer is C. Now, hopefully you've watched me solve that. This is sort of the first time I've tried to solve that question. Hopefully you've seen me solve that and seen that I really think that thinking is sometimes a little bit overrated. It's obvious what style of a question this is. So maths teachers aren't that creative. Think about what they would be trying to do and then just start doing it. It's clearly related rates. Start shoving some numbers in, see where you end up. That's fun. Let's do the next one. We're still in Victoria, 2009. Give yourself 90 seconds. Alright, I'm going to solve this one in 3, 2, 1. Let's go. Alright, I have thought about this question because I really like this question. So I'm going to show you 2 different ways to get this done. This is the intuitive way that I would be approaching this, right? So a complex number sits on an Argand diagram. Let's call that Z, right? Alright, that means that the conjugate is right down here, right? That's the conjugate. Now, negative of the conjugate, so if this is my complex number like that, right? Negative of that complex number is over here like that. Okay, so I've gone from Z to the conjugate of Z to negative of the conjugate of Z. Now, what is the distance between those points? Well, it's the distance from here to here plus the distance from here to here, and they're the same distance, right? So it's 2 times the real component of our original z value, because this portion here is the real component of our z value. So if our z value was 2 plus 3i, then this value would be 2. And the distance is going to be 4, so the answer here is A. Now, a lot of people are going to look at that and they're going to hate it. You certainly don't have to solve it that way. That's how it's popped into my head. So let's make the points something like A plus BI, which of course means that the conjugate, so if Z is equal to A plus BI, the conjugate of that is equal to A minus BI, which means that the negative conjugate is equal to negative A plus BI. And then it says, what is the distance between the 2 points? So to find the distance between 2 points, you just subtract one from the other, right? So we've got Z, and we're going to subtract negative Z. So A plus BI minus A plus BI. So A minus A is 2A, and BI minus BI, they cancel each other out. So 2 times A, which is the real component of Z, my answer is A. Alright, so you can attack it geometrically, you can attack it algebraically. It doesn't really matter what you do here. Why not both? It's a good way to do it. Alright, next question. Alright, we're in South Australia, 2021, just last year. We're worth 6 marks here. We've got 1 mark here. We've got 3 marks for part B, 1 mark and 1 mark. So give yourself about 9 minutes. The figure below, it's referencing these 4 pictures here, by the way. Alright, give yourself a try. And I'm going to solve it in 3, 2, 1. Let's go. Write the system of equations as an augmented matrix. Alright, so it's only 1 mark here, but some people might get a little bit stumped because there's all these m's and things going on. Alright, so x plus y equals 0. So we're going x, y, and z here. So 1x, 1y, 0 z's equals 0. So there's our first bit. We've got an mx plus z. So m is our x value, 0 for our y value, and 1 for our z value. And this bit here is m squared minus 1. And then last of all, we've got m for our x value. We've got 2m for our y value. And we have 3 minus m squared for our z value. And we've got a 0 there, 1 mark. Okay, so using clearly stated row operations, show that the system reduces to this thing here. So this is my answer to part A. I've just shifted that down. Now, what row operations do I need to do? So I'm trying to get this, and this to equal 0. So first step, let's try to get these and these to equal 0. The way to do that is to subtract some multiple of row 1. So don't have to think too much before we really get going here, because we still have to write out the first row when we do this. So there's our first row. Now, 1 times what is m? And of course the answer is m. So I'm going to subtract the first row from this row, but the first row multiplied by m. Let's write it. So row 2 dash is going to be equal to row 2 minus row 1 times m. So 1 times m is m, m minus m is 0. 1 times m is m, 0 minus m is minus m. Okay. 0 times m is 0, 1 minus 0 is 1, and m times 0 is 0, m squared minus 1 minus 0 is m squared minus 1. Alright, so there's our first step. We pull the same stunt here. R3 is going to be equal to R3 minus, same deal, we're still trying to get rid of an M, so minus M times R1 or R1 times M. So, that's going to be 1 times M is M, M minus M is 0, that's what we're aiming for. 1 times M is M, 2M minus M is M, and this bit's going to, these two are going to be unchanged. 0. Alright, so that looks pretty good. If we look where we're aiming for this here. And you can see my row looks wrong there, so we'll fix that up. And we're aiming for this here, and so we need to get rid of that 0 there. Alright, so doing those two things, 1, 1, 0, boop, 0. Now, I can multiply a row by something. It doesn't matter what multiple I multiply a row by. It doesn't change the matrix. So I'm going to multiply row 2 by negative 1. So negative 1. R2. So that's going to be 0 remains 0. Negative M becomes M. 1 becomes negative 1. And this becomes 1 minus M. And for clarity, I'm going to do the last bit after this. So we'll keep this one as it is. 0M, 3 minus M squared, and 0. Alright, in this last one, I'm going to subtract R2 from R3 to get rid of this M here. So first two rows remain unchanged. 0, M, negative 1, and 1 minus M squared. And then this next one, R3 is going to be equal to R3 minus R2. So 0 minus 0 is 0, M minus M is 0. Now 3 minus M squared minus 1 is going to be 4 minus M squared. And then 0 minus 1 minus M squared is going to be M squared minus 1. Alright, let's look if that's what we were aiming for. Okay, it's not what we were aiming for, right? Because I've got 4 minus M squared here. They've got M squared minus 4. I've got M squared minus 1 there. They've got 1 minus M squared. That's fine, because we can do that same thing with the row operation. So we can multiply that bottom row by negative 1. So we've got 0, 0, M squared minus 4, and what are we aiming for? 1 minus M squared. And what did we do there? Row 3 is equal to row 3 times negative 1. Alright, we should be good there. Looks good. 1, 1, 0, 0, 0, M, negative 1, 1 minus M squared, and 0, 0, M squared minus 4, 1 minus M squared. Now, have I done that the most efficiently of ways? I very much doubt it. I think there's a more efficient way to do that. Do I mind? No. The time that it's going to take to do something, to think about how to do it more efficiently and then do it more efficiently, is probably just as long as it takes to actually just do it inefficiently, but keep going. Come at me in the comments. So the next part of this question says state a value of M for which there is a unique solution. Now, what value of M wouldn't have a unique solution is a question. A value that made this bit equal to 0 wouldn't have a unique solution. So we want to avoid that. So M squared minus 4, what M value would make that equal to 0? 2 or negative 2 would make that equal to 0. So not that. Let's just go with like M equals 1. But I'm putting a question mark there because I don't know if that's true or not. So let's see. If I make M equal to 1, this bottom bit becomes 1 minus 4, which is negative 3. Z equals 1 minus 1 squared, which is 1. So I get negative 3z equals 0. So z equals 0 divided by negative 3, which is 0. Okay, that's fine. Z can equal 0. If I sub that into like this next line, so I've got like an M, which is, again, we said it was 1. So we've got 1y, which is just y. We've got a negative 1z, I believe, but our z is 0 here now. So y equals 1 minus m squared, 1 minus 0, which means that y is equal to 1. Okay, that's fine. So if y is equal to 1, so we've got 1x plus 1, because y is equal to 1, plus 0z equals 0. That means that x is equal to negative 1. Okay, that leads me to a unique solution of x is equal to negative 1, y is equal to 1, and z is equal to 0. So m equals 1. I'm happy with that. Okay, so we come to the last part of the question, which is which figure below represents the solution to this system for m equals negative 2. Now, I already said that m equals negative 2 causes an issue, so let me sub negative 2 into this totally so that you can see what's going on. Okay, so the green stuff is where I've subbed in m as negative 2. I've already done the calculations here. We note this 0, 0, 0, negative 3. Now this can be interpreted as the very strange 0 equals negative 3, which is of course nonsense. So we interpret this as there is no solution here. These three planes do not meet at a point and they do not meet at a line. So that means that we can get rid of this one here where the three planes are, and we can get rid of this one here where they're meeting at a point. And so now the question becomes, is it figure A or is it figure D? Now this one here you can see implies that two of the planes are running parallel to each other. And if we go back to our initial question, for them to be parallel to each other, two of the rows would need to be multiples of each other. So this would have to be like, if this was 1, 1, 0, then the next one would have to be like 3, 3, 0. But this is not the case here. They're not multiples of each other. So no combination of the three multiples of each other, which means that no combination of two of the three are parallel to each other. So we can get rid of this one. This is the one that we're looking for if m equals negative 2. We have no unique solution, line or point. All right, thanks South Australia. That was a good one. Last question. All right, we'd visit Tasmania for the first time, 2018. 6 minutes, 6 marks, so about 9 minutes. Give it a crack. All right, I'm going to solve it in 3, 2, 1. Let's go. Okay, so we need to consider two things here. This part here and this part here. And you can consider them completely separately until the end. So we want some complex number where the argument is between pi on 4 and pi on 3. So what does that look like? So we have pi on 4, which we should get, okay, like that. And we have pi on 3, 60 degrees. So something more like that. Okay, so far, so good. It's tempting at this stage to like shade all of this in, but we don't know what's going to happen here, so we're going to leave our shading to the end. The next part here is some form of circle, right? We have a complex number, -1, so the distance between those two things is less than or equal to 1. So you can think about this geometrically or you can think about it algebraically. The distance between a complex number and 1 is like right here, right? Let's say that's 1. The distance between a complex number and the number 1 is less than or equal to 1. That means that we have a circle that looks something like that. Let's try again. All right, so that's the best I'm doing here today. I have a circle of radius 1 with a center at point 1, 0. Now, if you're not happy with what I've done there, you can approach it algebraically as well by saying, okay, z's a complex number. Let's call it x plus y I, and we're subtracting the 1 from it, x plus y I minus 1. So then that's going to be less than or equal to 1. And then we've got the real components here of x minus 1 and the complex component of y. Now we're trying to find the distance here, the absolute value. So that's going to be equal to the square root of this bit squared plus this bit squared. Should probably tidy this up. Okay, and that's got to be less than or equal to 1. And so you can see now we have that circle equation. Okay, because if I square 1, I get 1. All right, so if we were to colour that in, we would get this bit here, right? But we need the intersection of those two things. The shaded bit that includes the circle and includes this part here. And zooming in, we've got this piece here. Okay. Importantly, it says you should determine and show any key points. Now, key points, what are they? Well, we've got something going on here at the origin, so that's 0, 0. We've got some key points for the circle, but I'm not sure if we include them as key points, right? Because the circle doesn't really matter so much as this shaded bit. But anyway, we'll label them up as well. So that's like 1, negative 1. This is 2, 0. And this point, which I think is definitely a key point, because it's one of the boundaries of our subset. This is a 45-degree line, right? So it's x value always equals its y value. We have a point on our circle that is 0.1, 1. That's where those are going to meet. 1, 1. Now the bigger question is this point here. Now I've sort of laboured over how I should approach finding that point, because there's a few different ways that I can think of approaching this. You could sort of use like a unit circle-y kind of approach. You could use like a circle theorems approach. I'm thinking like angle at a semicircle. But I'm going to use simultaneous equations here because I think even though it's probably maybe the longer way to get this done, it's the one that we'll be most familiar with. So we're trying to find the intersection of two equations. The equations are the circle, so x minus 1 squared plus y squared equals 1. So that's going to be our equation 1. I'm not worrying about this less than because we want to find the intersection on the actual outline of the circle. And the other equation that we've got a straight line that's making an angle with the x-axis of 60 degrees. So that's going to be y equals tan 60x, right? That's the gradient of that line. And tan 60 is just root 3 over 1, root 3. So we have y equals root 3x. And now hopefully you can see where I'm going. We've got to sub in root 3x in for y there. Alright, so you can see I've subbed that in, x minus 1 squared plus root 3x all squared equals 1, which is equal to x minus 1 squared plus 3x squared equals 1. I guess we'll expand that. X squared minus 2x plus 1 plus 3x squared equals 1. And then we're solving that, right? So we've got 4x squared minus 2x equals 0. Okay, so this comes out pretty neatly because we've got a common factor here of 2x. And then 2x minus 1, I think that's right, equals 0. So that means, therefore, so either 2x equals 0, which means that x equals 0, and we expect that because that's our intersection point right there, or 2x minus 1 equals 0, which means that x equals 1/2. Okay, fantastic. So coming back here, we know that this point is 1/2 something. Okay, what's the something? What's the easiest way to figure out the something? Probably here, by subbing x equals 1/2 into that. So x equals 1/2, y equals √3 times 1/2, y equals √3 on 2. Okay, and you can see that those numbers, that 1/2 and √3 on 2, they should be familiar to you. This is a unit circle that's been shifted over a little bit, and 1/2 and √3 on 2 are specific and important points on a unit circle. So when I was talking about like doing this geometrically and not doing this whole thing here, there are other ways to come to that point as well, and I invite you to play with those other ways. So it's a good idea at the end of a question to check that what you've done has done what the question's asked you to do. Sketch and clearly identify the region of the Argand plane that represents the set of complex numbers. Okay, so it does look like I've done that, and it says you should determine and show any key points. And it looks to me like I couldn't have shown any more points here. I've shown that point, I've put that point there. And I've also shown that. Now, I'm being careful, less than or equal to, less than or equal to, less than or equal to. So no dotted lines here. Wouldn't be surprised if they snuck some dotted lines in there somewhere, but I think we've done it. All right, let's tick some stuff off. So we did 2 tech-free ones, and we did 2 tech-free short responses as well. All right, and that's it for today's one. Keep going, study. Good luck.